Let's just talk about the visual representation of histograms and polygons. A histogram, you'll remember, is like the column graph when we're doing it stats. And so some things to keep in mind when you're drawing a histogram. So the column is centered on the actual score. Now those values are sometimes called the bins. This column graph, you don't put gaps between the columns, they all join up. So there's a histogram of the number of pets. So back to that example again. Now I know some of you are thinking, hang on a sec, don't we leave a gap at the front? Because I know in junior school a lot of people, they leave a gap. And I'll explain why in a sec, why we don't need to. That's a cumulative frequency histogram. So we build up the frequency. Polygon. Polygon is the line graph. So when we draw this one, the plotted points are in the center of the column. So that way it ends up directly above the value. So back to our histogram. So the top of each column in the middle, directly above the score, I've plotted the point. But the other thing we do is we start the polygon at the previous bin and also finish it at what would be the next bin. So we draw it like that. So you'll notice, actually on the left, I've started on the left-hand side of the axis. I mean, it's just an axis, I can put it anywhere I like. So what you traditionally would have done in the junior school is you probably would have put your axis where I put that dot, and hence why you ended up with a gap from the axis to that. It doesn't really matter. I mean, if you prefer to do it that way, we'll do it that way. And on the right-hand side, we've joined it up to wherever 5 would be. Cumulative frequency polygon, we do a little bit differently. We start, well, the very first rectangle, basically we draw the diagonal in. And then we always just join it up to the opposite vertex. So it would look something like that. So that's our cumulative frequency polygon, also known as the ogive, or ogive. I say ogive. Now when you have group data, you see when you've got lots and lots and lots of scores, sometimes it's not practical to come up with an axis which has every single possible score. So we group scores together, called classes. Now, how do you group your data? It's got to be inclusive, so every score that appears in that class would go into there, but not overlapping. There can be no ambiguity about which class a score goes into. Every score will belong to one and only one class. So that brings up the problem with what happens if the score's on the boundary. You just have to make a decision. But once you make that decision, it's the same decision for every class. So if you decide you're going to place the boundary in the lower one, then they must always go in the lower one. If you decide it will go in the higher one, then it must always go in the higher one. It really doesn't matter which way you go, but in stats, if you were presenting a report, you would say how you dealt with the data. So that would be part of the information you would give. Rough idea there. Number of classes, yeah, usually about 5 and 10. But that's not a hard and fast rule. That's generally, keep about that. They've got to be the same width. And how do you work it out? Well, it's the range divided by the number of intervals. That tells you what the width is. And always round up if it's not an exact amount. When you're using classes for calculations, whatever the value of the class center is, that's the value you use. You assume every score has that value. So we've got heights of 300 students. Now, clearly it would not be practical to have an axis where we had everyone going from 120 all the way up to 200. So this is a good example of why we would put it into groups. And so there's our frequency of those particular groups. So we're going to find the mean, the median. Well, it won't be a median now though. It'll be a median class. So it's which interval it falls in. Same with the mode. It's not going to be a mode now. It's going to be a modal class, which group it falls in. So we do our table same as normal. So the next column becomes fx. What will our average be? Will be the sum of fx divided by n. Now, this is different to what we did last year because here I'm dealing with the actual frequencies, whereas last year, remember, we dealt with probabilities. So we didn't have to divide by n because with probability, you always put it over n in the probability itself. So in this case, we do have to divide by n and we end up with 156.5. Now, the standard deviation, so we work out the variance first. Well, that's going to be the sum of fx squared, but again, we're going to have to divide that by n because we're not dealing with probabilities here. We're dealing with the actual frequencies. And subtract the average squared. Remember, it was what we had last year was the expected value of x squared minus the expected value of x squared. So it's still the same idea. We get 262.75, so to find the deviation, we find the square root of that, 16.21. Okay, what else do we have to find? Cumulative frequency helps when we're finding things like the median, because we need them to be in order. That's what we just found before. So we found that 156.5 was the mean. The median class, now that I've got them in order, 150 to 160, it falls into that particular group. The modal class, the one that happens the most, is the one that goes from 150 to 160 as well, by coincidence. The variance, we worked that one out. Deviation, we worked that one out. Now, if we want to calculate the actual median and not the median class, that's where our cumulative frequencies really come in handy. Because I'll now draw the cumulative frequency diagram, or histogram. So the cumulative frequency histogram. Draw in the ogive, and we know the median is going to be 50% of the data. That would be a frequency of 150. So I read off the graph. Now it looks like it's in the center and it's 155, but it's not. We can actually calculate it out. If we just look at that particular one. So the left-hand side of it was at 150, and that had a frequency of 99 at that point. 160 had a frequency of 199. We want to know what had the frequency of 150. And basically we've got similar shapes there. That will work it out. Now where do all these numbers come from? Okay, 150 is where we're starting from. So I know it's going to be 150 plus something. What's it going to be plus? I know 150 minus 99. That's the difference in the heights. 150 minus 99. And I'll divide that by the height is 100. We're going from 99 to 199. So basically I'm saying it's that proportion. How far up have I gone? It's that proportion. And therefore it must be the same proportion on the base, which is 10. And that works out, it was close to 155, but no, it's 155.1. 15B.